Imagine you're sitting at your computer ready to send a simple message. Hello, world. It's a phrase that has become synonymous with the beginning of a new adventure in the world of programming and communication. You hit send, and instantly it seems the message pops up on your friend's screen across the globe. It's almost magical how quickly and seamlessly this happens, bridging vast distances in the blink of an eye. But what happens in between? What processes are at play to make this instantaneous communication possible? How does this seemingly simple message traverse the vast expanse of the internet? The journey is more complex and fascinating than it appears on the surface. The answer lies in the fascinating world of computer networks. These networks are the backbone of our digital communication, enabling the transfer of data across the globe. Think of the internet as a complex system of roads, highways, and intersections. Just like a city's infrastructure, the internet has its own pathways and routes that data must travel through. Your message, "Hello, world," is like a package that needs to be delivered. It must be carefully routed and handled to ensure it reaches its destination intact. To reach its destination, it embarks on a journey through this intricate network guided by addresses and protocols. These protocols act like traffic rules, ensuring that data flows smoothly and efficiently. This journey involves breaking down the message into smaller parts, like packing a suitcase. Each part, or packet, contains a piece of the message and the necessary information to reassemble it at the destination. Each part travels through different layers of the network, much like taking different modes of transportation, from cars to airplanes to delivery trucks. These layers ensure that the data is transmitted accurately and efficiently. Join us as we unravel the mysteries of network communication and follow the journey of Hello World, from your fingertips to your friend's screen. We'll explore the technology and processes that make this incredible feat possible, shedding light on the unseen world of digital communication. To understand the Internet's inner workings, we need to learn its language, the TCP/IP model. This model is fundamental to how our digital world operates, enabling seamless communication between devices across the globe. This model acts as a set of rules that govern how data is transmitted across networks. Without these rules, the Internet as we know it would not function, as devices would be unable to communicate effectively. Think of it like a postal system, with different departments working together to deliver mail. Each department has a specific role, ensuring that your letter reaches its destination. The TCP/IP model consists of 4 layers: application, transport, internet, and network access. Each layer is crucial, working in harmony to manage the complex process of data transmission. Each layer has a specific role, ensuring that data reaches its destination accurately and efficiently. This layered approach simplifies troubleshooting and enhances the reliability of data communication. At the top, we have the application layer, where users interact with software like web browsers and email clients. This is the layer most familiar to everyday users, as it includes the applications we use to access the Internet. It's like writing a letter and addressing the envelope. The application layer ensures that the data is properly formatted and ready for transmission. The transport layer then divides the message into smaller packets and adds information like port numbers, ensuring reliable delivery. This layer is responsible for maintaining the integrity of the data as it travels across the network. This is similar to sorting mail into different bags based on their destinations. The transport layer ensures that each packet is sent to the correct location and reassembled in the right order upon arrival. The Internet layer comes next, assigning unique IP addresses to each device on the network, like putting a street address on the mail. This layer is crucial for routing the data packets to their correct destinations. Finally, the network access layer handles the physical transmission of data over the network, representing the mail carrier delivering the letter to your doorstep. This layer deals with the hardware and protocols needed to actually move the data from one point to another, ensuring that the entire process is completed successfully. As our Hello World message travels down the TCP/IP layers, it undergoes a process called encapsulation. Imagine packing a gift, You start with the gift itself, then wrap it in paper, put it in a box, and finally add a shipping label to it. Encapsulation works similarly. At each layer, the data is wrapped with additional information, forming a new unit. At the application layer, our message is just plain text. The transport layer adds a header, creating a segment. The internet layer then adds its own header, turning the segment into a packet. Finally, the network access layer adds a final header and trailer, forming a frame. Each header contains crucial information for the corresponding layer at the receiving end. It's like the address label, return address, and special instructions on a package, ensuring it reaches the correct destination and is handled properly. Before our message can embark on its journey, our computer needs an address on the network. This address is crucial because it acts like a home address, ensuring that data sent across the network reaches the correct destination. This is where DHCP, or Dynamic Host Configuration Protocol, comes in. It's a fundamental part of modern networking. Think of DHCP as a dynamic address book, assigning unique IP addresses to devices upon request. This process is automated, making it easier for network administrators to manage large networks without manually assigning addresses. When your computer connects to a network, it sends out a DHCP request, like asking, "Can I have an IP address, please?" This request is broadcasted to all devices on the network, but only the DHCP server responds. The DHCP server responds with an available address, allowing your computer to communicate with other devices. This address is leased for a specific period, after which it can be renewed or reassigned. But what happens when there's no DHCP server available, like in a small home network? In such cases, your computer still needs an IP address to communicate with other devices. That's where APIPA, or Automatic Private IP Addressing, comes in. APIPA is a self-configuring mechanism that assigns a private IP address to the computer automatically without the need for a DHCP server. APIPA assigns an address from a specific range, typically 169.254, x.x, ensuring that the computer can still participate in the network. This is particularly useful in small or temporary networks. It's like your computer choosing a temporary address to use within a small group. This allows for basic communication and file sharing between devices, even without a central server. These address assignment protocols, DHCP and APIPA, ensure that every device on the network has a unique identifier. This prevents communication chaos and ensures our "Hello World" message reaches its destination efficiently and accurately. Whether in a large corporate network or a small home setup, these protocols are essential for seamless connectivity.